Consider the real valued function f of x, which is defined with braces, defined in two different manner depending on its domain, a portion of its domain. The first definition is negative x plus 1 for all values of x less than or equal to 3. And then the second definition is kx minus 8 for all values of x greater than or equal to 3. All right. Question A, we're asked to find the value of k. And then question B, we're asked to find the value of the function at negative 10 and the value of the function at 10, and also the composite function f of 5. All right, so let's start. Our function f of x is defined in two different manners depending on the portion of its domain that we are working on. For all values of x less than or equal to 3, the function is defined as negative x plus 1. And for all values of x greater than or equal to 3, the function is defined as kx minus 8. Now, such type of functions, we have to be careful, defined in such a manner. What is the domain of this function? The domain of this function clearly is all of the real number line. All of the real number line. All right? But we have particularity at, there's some particularity at the number, at the point 3 on the number line. Less than or equal to 3 means all values from 3 backwards this way. Greater than or equal to 3 means all values again from 3 up this way. So, for all values this way, all values of x from 3 backwards to negative infinity, remember this is negative infinity, this is positive infinity, the function is defined here as negative x plus 1. For all values from 3 again, getting towards positive infinity, the function is defined as kx minus 8. That's the meaning when we see function defined in such a manner. We go to the domain, we check out the critical point here is 3, and then we see we place the definitions, the different definitions on the depending on the zone that we find ourselves. All right. So, but there's something very important here. We see 3 is involved this way, and 3 again is also involved this way. That's why this portion, this indicator is shaded. Okay, the circle there is shaded. 3 belongs this way, and 3 belongs to that definition. So, for us to be able to get the value of k, all right, the first part of our question is to find the value of k. It simply means that we will find the function value at 3, since it is defined this way and also defined this way. So, function value at 3, f of 3, will be negative 3 plus 1, and that will give us the same value as, all right, that's f of 3, and here f of 3 again. Let's first of all define them separately. F of 3 is found this way, f of 3 is also found that way. So we'll have 3 multiplied to k is 3k minus 8. 3k minus 8. All right. Now, since the left-hand sides are equal, we have the right to equate the right-hand sides also. F of 3, f of 3. It therefore means that this expression must be equal to this expression. So we now write negative 3 plus 1 must be equal to 3k minus 8. Negative 3 plus 1, we can read it this way. We can say 1 minus 3, it is negative 2. So we have negative 2 is equal to 3k minus 8. Remember, I want to solve for k. So we take this negative 8 from the right-hand side to the left-hand side. It is negative 8 coming over here becomes positive 8. All right. So we have 8 minus 2 is equal to 3k. 8 minus 2 is 6. To get k, we simply divide both sides by 3. And so the value of k is 2. Therefore, the function of x for all values of x greater than or equal to 3 will now replace k with its value, will be 2x minus 8. That answers the first part of our question. So we can now be able to answer the second part of our question, which is B, question B. So we now say our function now, in the place of k, we just put 2. We now have the complete definition of our function. So what is f of, we're now solving B, what is f of negative 10? Now we look, the value of x here is negative 10. So where do we have negative 10 if we look at the domain of our function? Negative 10 is somewhere this way. It's to the left of it's on the left of this 3. So negative 10 is this way. What definition are we going to use? Definitely this is the definition. So negative 10 we'll use by this definition for our function. And so f of negative 10 will be negative into negative 10 plus 1. Now this gives us negative multiplied to negative positive. All right. So f of negative 10 will be 11. What about f of positive 10? Where do we have positive 10 on our domain? Positive 10 is to the right of 3. Remember, after 3, you have 4, we have 5, we have 6 right up to, and so 10 is this way. All right. So positive 10 is this way. What definition are we going to use? We have to use this definition, 2x minus 8. So f of positive 10 will be 2 of our x minus 8. This definition. X is now 10. So this gives us 20 minus 8, which is 20 minus 8 is 12. That gives us the value of f of 10. Now, what about the composite function f of 5? All right, f of 5. This composite function simply means f will implement itself. Okay, now let's write it here and do it in a much more elaborate manner. So let us first of all get our f of x. What is f of x? It is f carrying f of x. Now, what is, and we know our x here is 5. Okay, so which of the definitions are we going to use? Is it this one or this one? Is it this definition or this definition? We look at 5. 5 is to the right of 3. Look at 3, 4, 5. 5 is this way. So the definition we have to use is this one. So we'll use 2x minus 8. So this will be f of 2x minus 8. Now, what are the instructions of f? The instructions of f are whatever f carries, it multiplies by 2 and subtract it. Okay? Our f of x, let's write it again. Our f of x is 2x minus 8. Whatever f is carrying x here. What has it done to it? It multiplies to 2 and subtract 8 from the result. Now here, what is f carrying? F is carrying the expression f 2x minus 8. It will do the same thing. Functions are like sets of instructions. The function has 2 instructions here. Whatever it carries, instruction number 1, it multiplies by 2. Instruction number 2, it subtracts 8 from the result. So now it is carrying 2x minus 8. It will do the same thing. 2 instructions. Instruction number 1, it multiplies what is carrying by 2. Instruction number 2, it subtracts 8 from the result. It's as simple as that. Now open the parentheses. 2 multiplied to 2x gives you 4x. 2 multiplied to negative 8 gives you negative 16. And then minus 8. All right, negative 16 minus 8 is going to give you negative 24. So we have 4x minus 24. 4x minus 24. All right. This, therefore, is the expression for f of x. Now, f of 5 simply means we come and replace x with 5 in that expression. Where is x? This is x. So where we find x, we're going to put the value 5. It's simply 4 multiplied to 5 minus 24. 4 multiplied to 5 is 20. 20 minus 24 gives us negative 4. So f of 5 is negative 4.